Welcome back to the Get It Done Certified Practice Series for the AWS Certified Solutions Architect Associate, SAA-C03. This is episode 12 of 15 in the complete playlist. In this episode, we'll continue with questions 111 through 120, followed by the correct answers and explanations. Question 111. A company wants to use high-performance computing, HPC, infrastructure on AWS for financial risk modeling. The company's HPC workloads run on Linux. Each HPC workflow runs on hundreds of Amazon EC2 spot instances, is short-lived, and generates thousands of output files that are ultimately stored in persistent storage for analytics and long-term future use. The company seeks a cloud storage solution that permits the copying of on-premises data to long-term persistent storage to make data available for processing by all EC2 instances. The solution should also be a high-performance file system that is integrated with persistent storage to read and write datasets and output files. Option A. Amazon FSx for Lustre integrated with Amazon S3. Option B. Amazon FSx for Windows File Server integrated with Amazon S3. Option C. Amazon S3 Glacier integrated with Amazon Elastic Block Store, Amazon EBS. Option D. Amazon S3 Bucket with a VPC endpoint integrated with an Amazon Elastic Block Store, Amazon EBS, General Purpose SSD, GP2 Volume. The correct answer is A. Amazon FSx for Lustre integrated with Amazon S3. Explanation. FSx for Lustre provides a high-performance file system ideal for HPC and can seamlessly integrate with Amazon S3 for persistent storage. Why not option B? Amazon FSx for Windows File Server designed for Windows-based workloads, not HPC on Linux. Why not option C? S3 Glacier plus EBS Glacier is archival, not suitable for high-performance access. Why not option D? S3 plus EBS GP2, not a high-performance file system suitable for HPC needs. Question 112. A company is building a containerized application on premises and decides to move the application to AWS. The application will have thousands of users soon after it is deployed. The company is unsure how to manage the deployment of containers at scale. The company needs to deploy the containerized application in a highly available architecture that minimizes operational overhead. Option A. Store container images in an Amazon Elastic Container Registry, Amazon ECR, repository. Use an Amazon Elastic Container Service, Amazon ECS, cluster with the AWS Fargate launch type to run the containers. Use target tracking to scale automatically based on demand. Option B. Store container images in an Amazon Elastic Container Registry, Amazon ECR, repository. Use an Amazon Elastic Container Service, Amazon ECS, cluster with the Amazon EC2 launch type to run the containers. Use target tracking to scale automatically based on demand. Option C. Store container images in a repository that runs on an Amazon EC2 instance. Run the containers on EC2 instances that are spread across multiple availability zones. Monitor the average CPU utilization in Amazon Cloud Watch. Launch new EC2 instances as needed. Option D. Create an Amazon EC2 Amazon Machine Image, AMI, that contains the container image. Launch EC2 instances in an auto-scaling group across multiple availability zones. Use an Amazon CloudWatch alarm to scale out EC2 instances when the average CPU utilization threshold is breached. The correct answer is A. Store container images in an Amazon Elastic Container Registry, Amazon ECR, repository. Use an Amazon Elastic Container Service, Amazon ECS, cluster with the AWS Fargate launch type to run the containers. Use target tracking to scale automatically based on demand. Explanation: Fargate provides serverless container management with high availability and minimal operational overhead. Why not option B? ECS with EC2 launch type requires EC2 capacity management and adds overhead. Why not option C? EC2-based container repo not scalable or operationally efficient. Why not option D? AMI with auto-scaling inflexible and not container native. Question 113. A company has two applications: a sender application that sends messages with payloads to be processed, and a processing application intended to receive the messages with payloads. The company wants to implement an AWS service to handle messages between the two applications. The sender application can send about 1,000 messages each hour. The messages may take up to 2 days to be processed. If the messages fail to process, they must be retained so that they do not impact the processing of any remaining messages. Option A. Set up an Amazon EC2 instance running a Redis database. Configure both applications to use the instance. Store, process, and delete the messages, respectively. Option B. Use an Amazon Kinesis data stream to receive the messages from the sender application. Integrate the processing application with the Kinesis Client Library, KCL. Option C. Integrate the sender and processor applications with an Amazon Simple Queue service, Amazon SQS, queue. Configure a dead letter queue to collect the messages that failed to process. Option D. Subscribe the processing application to an Amazon Simple Notification Service, Amazon SNS, topic to receive notifications to process. Integrate the sender application to write to the SNS topic. The correct answer is C. Integrate the sender and processor applications with an Amazon Simple Queue service, Amazon SQS, queue. Configure a dead letter queue to collect the messages that failed to process. Explanation: SQS provides durable, decoupled message handling, and dead letter queues support long processing delays and message retention. Why not option A? Redis on EC2 high maintenance and not durable by default. Why not option B? Kinesis best for real-time streaming, not for long retention or low-frequency workloads. Why not option D? SNS push-based and not ideal for message retention or retry handling. Question 114. A solutions architect must design a solution that uses Amazon CloudFront with an Amazon S3 origin to store a static website. The company's security policy requires that all website traffic be inspected by AWS WAF. Option A. Configure an S3 bucket policy to accept requests coming from the AWS WAF Amazon resource name, ARN, only. Option B. Configure Amazon CloudFront to forward all incoming requests to AWS WAF before requesting content from the S3 origin. Option C. Configure a security group that allows Amazon CloudFront IP addresses to access Amazon S3 only. Associate AWS WAF to CloudFront. Option D. Configure Amazon CloudFront and Amazon S3 to use an Origin Access Identity, OI, to restrict access to the S3 bucket. Enable AWS WAF on the distribution. The correct answer is D. Configure Amazon CloudFront and Amazon S3 to use an Origin Access Identity, OI, To restrict access to the S3 bucket, enable AWS WAF on the distribution. Explanation: CloudFront with OAI restricts direct S3 access, and WAF can be associated with the CloudFront distribution for inspection. Why not option A? S3 bucket policy with WAF ARN not a valid configuration method. Why not option B? CloudFront doesn't forward to WAF. WAF is integrated at CloudFront level, not as a backend step. Why not option C? Security groups don't apply to S3. S3 doesn't use security groups. Question 115. Organizers for a global event want to put daily reports online as static HTML pages. The pages are expected to generate millions of views from users around the world. The files are stored in an Amazon S3 bucket. A solutions architect has been asked to design an efficient and effective solution. Option A: generate pre-signed URLs for the files. Option B: use cross-region replication to all regions. Option C: use the geo-proximity feature of Amazon Route 53. Option D: use Amazon CloudFront with the S3 bucket as its origin. The correct answer is D: use Amazon CloudFront with the S3 bucket as its origin. Explanation: CloudFront provides low-latency global content delivery from S3 with caching and edge locations. Why not option A? Pre-signed URLs used for restricted access, not efficient for public large-scale content. Why not option B? Cross-region replication not useful for user access performance. Why not option C? Geo-proximity routing applies to DNS-based routing, not content distribution. Question 116. A company runs a production application on a fleet of Amazon EC2 instances. The application reads the data from an Amazon SQS queue and processes the messages in parallel. The message volume is unpredictable and often has intermittent traffic. This application should continually process messages without any downtime. Which solution meets these requirements most cost-effectively? Option A: use spot instances exclusively to handle the maximum capacity required. Option B: use reserved instances exclusively to handle the maximum capacity required. Option C: use reserved instances for the baseline capacity and use spot instances to handle additional capacity. Option D: use reserved instances for the baseline capacity and use on-demand instances to handle additional capacity. The correct answer is C: use reserved instances for the baseline capacity and use spot instances to handle additional capacity. Explanation: this hybrid approach balances cost efficiency and availability by reserving steady-state capacity and scaling cost-effectively. Why not option A? Spot instances exclusively risk of interruption and not reliable for baseline processing. Why not option B? Reserved instances exclusively may lead to underutilization during low-traffic periods. Why not option D? Reserved plus on-demand more costly than using spot for scaling. Question 117. A security team wants to limit access to specific services or actions in all of the team's AWS accounts. All accounts belong to a large organization in AWS organizations. The solution must be scalable, and there must be a single point where permissions can be maintained. What should a solutions architect do to accomplish this? Option A: create an ACL to provide access to the services or actions. Option B: create a security group to allow accounts and attach it to user groups. Option C: create cross-account roles in each account to deny access to the services or actions. Option D: Create a service control policy in the root organizational unit to deny access to the services or actions. The correct answer is D. Create a service control policy in the root organizational unit to deny access to the services or actions. Explanation: SCPs provide centralized control over AWS service permissions across all accounts in an organization. Why not option A? ACL used for S3 and networking, not account-level permissions. Why not option B? Security groups used to control traffic, not service-level permissions. Why not option C? Cross-account roles not scalable or centralized. Question 118. A company is concerned about the security of its public web application due to recent web attacks. The application uses an application load balancer, ALB. A solutions architect must reduce the risk of DDoS attacks against the application. What should the solutions architect do to meet this requirement? Option A. Add an Amazon Inspector agent to the ALB. Option B. Configure Amazon Macie to prevent attacks. Option C. Enable AWS Shield Advanced to prevent attacks. Option D. Configure Amazon Guard Duty to monitor the ALB. The correct answer is C. Enable AWS Shield Advanced to prevent attacks. Explanation: Shield Advanced provides DDoS protection for ALBs and other AWS resources. Why not option A? Amazon Inspector used for vulnerability assessment, not DDoS prevention. Why not option B? Amazon Macie used for data classification, not attack prevention. Why not option D? Guard Duty detects threats but doesn't prevent attacks. Question 119. A company is implementing a new business application. The application runs on 2 Amazon EC2 instances and uses an Amazon S3 bucket for document storage. A solutions architect needs to ensure that the EC2 instances can access the S3 bucket. What should the solutions architect do to meet this requirement? Option A. Create an IAM role that grants access to the S3 bucket. Attach the role to the EC2 instances. Option B. Create an IAM policy that grants access to the S3 bucket. Attach the policy to the EC2 instances. Option C. Create an IAM group that grants access to the S3 bucket. Attach the group to the EC2 instances. Option D. Create an IAM user that grants access to the S3 bucket. Attach the user account to the EC2 instances. The correct answer is A. Create an IAM role that grants access to the S3 bucket. Attach the role to the EC2 instances. Explanation: the best practice is to assign IAM roles to EC2 instances for accessing AWS services. Why not option B? IAM policy on instance policies attached to roles, users, or groups, not instances directly. Why not option C? IAM groups apply to users, not EC2 instances. Why not option D? IAM user not intended for programmatic access from EC2 instances. Question 120. A company's web application is running on Amazon EC2 instances behind an application load balancer. The company recently changed its policy, which now requires the application to be accessed from one specific country only. Which configuration will meet this requirement? Option A. Configure the security group for the EC2 instances. Option B. Configure the security group on the application load balancer. Option C. Configure AWS WAF on the application load balancer in a VPC. Option D. Configure the network ACL for the subnet that contains the EC2 instances. The correct answer is C. Configure AWS WAF on the application load balancer in a VPC. Explanation: AWS WAF supports geographic restriction rules which are suitable for country-based access control. Why not option A? Security group on EC2 does not support geographic filtering. Why not option B? Security group on ALB also doesn't support location-based filtering. Why not option D? Network ACL controls IPs, not geographic origin. You've completed another episode. Follow Get It Done Certified for more practice sessions, and share this playlist with others who may be taking the same certification. When you're ready, move on to the next episode.